Dear students, greetings from Dr. T. Senthil Murugan, Associate Professor and Head, Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal College. In this video lecture, we are going to discuss about sparse matrix. In data structure, sparse matrix is used to reduce the memory which matrix have occupied more space which have more zeros values. So for that purpose, we are using the sparse matrix, and in this video lecture we are going to discuss about what is sparse matrix and how we can generate the sparse matrix and how it is useful compared with the existing matrix. Those things we will discuss in this video lecture. So this is the video lecture week 3 lecture 1, classroom discussion topic CDT 07, sparse matrix representation. So after completion of this lecture, before starting this lecture, we must be discuss about outcome of this lecture. So hence, after completion of this lecture, students will be able to develop a C program to create sparse matrix for the given matrix and able to compare the space with the normal matrix. How much space it is occupied in the normal matrix, how much space occupied by the sparse matrix. Those things the students will be able to analyze it. So what is matrix? Normally in programming we are representing rows and columns. Okay, so if the matrix is represented using number of rows and number of columns. Okay, so normally we can say M cross N matrix. So M may be number of rows and N may be number of columns. Okay, row and cross row and column. Based on that we can represent it. In matrix, in C programming, how we can represent using array. Okay, so for example, A is the array means, so we can represent row in that square bracket. So another square bracket we can write column. Normally we can mention two-dimensional array. Using two-dimensional array we can represent the matrix. Okay, so what is sparse matrix? Sparse matrices are those matrices that have majority of their elements equal to 0. If in case you will take 3 cross 3 matrix. Okay, so the matrix 3 rows and 3 columns are there. You just assume that. Okay, so I will give the values 0 0 0 0 1 0 1 0 0. So in this matrix, you just consider only 2 elements are non-zero elements. The remaining all are zero elements. For this matrix, if we are declared integer data type, if integer will take more 4 bytes means, so here 9 values are there. 9 into 4, 36 bytes will be allocated for this array. So instead of allocating 36 bytes, we can allocate memory only for non-zero elements. Okay, we have to allocate only memory for non-zero elements. Remaining the zero elements will be omitted. That is considered as the sparse matrix. Okay, so what we have to do, sparse matrix can be defined as matrix that has a greater number of zero elements than the non-zero elements. So now the question arises. What is the question will come? You can also use a simple matrix to store the elements. Then why is the sparse matrix is required? So we are using normal matrices. We know that if 3 cross 3 means only 9 elements is there. So based on the 9 elements, memory will be allocated. What is necessary to create this sparse matrix? So we have two options. Okay. So when we are going for sparse matrix, the first one is storage. When we are thinking about storage, we will go for sparse matrix. So whatever I said in the previous slide, if non-zero elements, we have to allocate memory. But if the zero element means we can omit it. So if less memory can be used for store the elements. As well as if you want to perform some operation, so example, if you want to evaluate, so it evaluate only non-zero elements. No need to check all the zero elements. Only we have to check non-zero elements. Second one is computing time. What is computing time? How much time it will take to perform the operation. If example, traversal operation, you just consider traversal operation. What is the traversal operation? We have to visit all the nodes at least once. So if wherever the values are there only we have to visit. The remaining elements are zero now, so no need to visit. In that situation, if in case 3 cross 3, same matrix will take. 9 elements are there. Only 2 elements are non-zero elements. Okay, so remaining all are zero elements. So when I am applying the traversal operation, we can only traverse with these two values. No need to search or visit all the elements in the zero elements array. So when we are comparing with the normal matrix, only we have to visit non-zero elements. Based on that, the computation time is very less. Okay, in sparse matrix, we have to visit only non-zero element. How to represent the sparse matrix? Sparse matrix will be represented using two types. One is array representation, another one is linked list representation. We will discuss about both representations. What is array representation? If array representation means, first we have to take the elements. Before going to that, we must be understand what is sparse matrix. Okay. So now you consider this matrix. In this matrix, 4 cross here 5 cross 4 matrix is there. Okay. 5 rows and 4 columns are there. So totally 20 elements are there. So out of 20 elements, how many non-zero elements are there? 1, 2, 3, 4, 5, 6, 7. Only 7 elements are non-zero elements. Remaining 13 elements are zero elements. So in this situation, how we can do that? 5 into 4, 20 memory space we require. Okay. Increasing the size of the matrix will increase the wastage of the spaces. So for that reason, how we can do that? So the above matrix we have to convert into like 3 rows with number of columns. How many non-zero elements? That many columns will come. Okay. So first what we have to do? Where is the values non-zero element is there? 0. Row 0, column 1. So row 0, column 1. So we know that the position of that matrix values no 0, 0, 0, 1. So this one 0, 2, this one 0, 3. First row means row 0 is first row, but we will perform all the columns 0, 0, 0, 1, 0, 2, 0, 3. Next 1, 0, 1, 1, 1, 2, 1, 3. Next 2, 0, 2, 1, 2, 2, 2, 3. Like that we can represent. So in that wherever the non-zero elements are there, first 4 is there, then 5 is there. In second row 3 is there and 6 is there. And third row only 2 is there and fourth row only 2 is there. In fifth row only 1 is there. When we are comparing this, how many elements are there total? 2, 4, 6, 7. Only 7 elements are there. Okay. So in this 7 elements, you just consider how many columns are there. Row is 5, column is 4, and here number of non-zero element is 7. So now you just consider how much memory it will take. Row into column into value. Okay. So here only 3 row is there. Okay, so this is one row, this is another row, this is another row. So 3 row is there. And how many non-zero element is there? 7 is there. So if array of 3, 7, it can use to represent this array. How much memory it will take? 3 into 7, 21 elements, 21 bytes it will take. Okay. So array representation of the sparse matrix. How we can represent the sparse matrix using array? So we already know that we have to use 3 values. Okay. So wherever we are, whenever we are discussing about matrix, we know it will be represented using row and columns. Okay. Rows and columns. So normally it is used to represent the 2-dimensional array. So if we want to represent the matrix, means we need 2 rows and columns. But if you want to represent the sparse matrix, one more element is required. What is that one more element? Row value, column value, and non-zero element values, that is value. Okay. Which row, which column, what is the value? So like 3 elements we need to represent the sparse matrix. Okay. So what are the things we need? First one, row, index of row where non-zero element is located in the matrix. Index of column where non-zero element is located in the matrix. Row and column, we know that how to represent it. So finally value, which value is located in the particular row and column indexes. Okay. So we can represent like this, row, column, value. So now we are going to discuss about program. So if we see the program, we are easily understand how it is working. So this topic here, whatever the theory part is there, that already we are discussed while explaining the normal matrix to sparse matrix. So now we will check about how to write the program. So you see here, if example, okay, so we will consider that previous table. Okay, if size of the table depends on the total number of non-zero elements. So for example, 8 into 3, okay, 24 memory space, which more than space occupied by the sparse matrix. Okay. So that means normal memory it will take only 20, but it will take 24 bytes. So if you take more memory, then why we will go for sparse matrix? Sparse matrix is useful for more elements in the array. For example, 8 cross 8 matrix is there. How many elements are there? 64 element is there. So if out of 64, only 8 values are non-zero element, means we can use only 24 bytes. Okay. So otherwise, if the small number of small size of the array or matrix, if we are using sparse matrix, it will occupy more space. So then when the sparse matrix is useful, the matrix have more size. More means compared with the small size. If example 7 cross 7 or 8 cross 8 matrix, so 8 cross 8 means 64 values. Out of 64, if 10, 15, 20 values are there, remaining all are 0, then it is useful. Okay. So see here in this example, first I will declare the sparse matrix array name and size is row and column, 4 row and 5 columns. So I am initializing the value with this value. So this is the first row, this is the second row, this is the third row, this is the fourth row. So 4 row is there, and then how many elements are there? First column, second column, third column, fourth column, fifth column. So 5 columns are there. Totally 4 into 5, 20. So 20 elements we are given as value for this array. So now we have to find the size of the array. How many element is there? We don't know. So we have to calculate. Okay. So how many elements initially? Row and column. We have to read the values. Okay. So if that the already we are given the matrix value. So we have to check wherever the 0 elements are there. So for that, initially first row I we will take as the row. So this will be represented for row. This loop will be represented for column. So each row and column, okay, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 0, 4, up to 0, 4 it will take because less than 5. So then I value will be incremented 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. Up to 4 it will check. So like that, each and every element it will check in the matrix. If how many non-zero element is there, that we are going to check now. So for that we are writing size plus plus. What is the size value? Initially 0. So whenever the non-zero element is there, it will increase the size. Okay. So now if non-zero element means size value will be incremented by 1. So like that, the entire loop is executed, means the total number of non-zero element we are able to identify. What is the final size of the matrix in the sparse matrix? So we know 3 row compulsory we need. One is row represent the row, another one is represent the column, another one represent the value. So that is 3 row we are using. Okay. So 3 row is fixed. And remaining, how many non-zero element is there? We don't know. That only we are calculated here. Size plus plus. That we will give 3 into size. Okay. Already we are calculated the size value. So now we are allocated the memory for sparse matrix. Okay, so initially k equal to 0. So just we will fix the value k equal to 0. So we have to check again all the elements. So what we have to do, sparse matrix, how we can find it? So if the sparse matrix non-zero element is there, means we can store that value into where it is located actually. Okay, so initially where it is located. So first row 0, k value will be incremented 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Then like that it will identify, it will print. Okay, so first value is I value. If it is found, it is the I value, and 1 comma k equal to j value, and 2 comma k equal to sparse matrix of I comma j value. 0, 1, 2, 3 is repeat. So this loop will be executed. Okay, whenever the values are non-zero element, this loop will be executed. Okay, so then k value will be incremented. Initially 0, 0, 1, 0, 2, 0 is the value stored for the first element, non-zero element. The second non-zero element, k value will be incremented. 0, 1, 1, 1, 2, 1. It will comes for second column. Okay, so like that column wise we are storing the value. Okay, so it will be stored. After storing it, we have to print the entire array using that for loop. We are printing the matrix using for loops. What is the output? So this program. So this is the output. Okay, so here 3 row is there. First one represent row, second one represent column, and third one represent the value. So this is the first column, k equal to 0 column. So second column k equal to 1. Like that it will be stored the value. Okay, 0, 0, 1, 0, 2, 0. At next 0, 1, 1, 1, 2, 1. Like that it will store. Okay. So final output is represent the row column values. So how many columns are there? Totally how many values are there? So here 3 rows into how many columns are there? Totally 1, 2, 3, 4, 5, 6. 3 into 6, 18. So 18 values are stored this array. Okay. So actually 20 elements are there. Now it will take only 18 elements. Okay. So next second point is linked list representation. So here it's the same like array representation, but while we are going for discuss about linked list, one more element should be there. What is that element? That is the next node elements. The pointer is pointing to where the next element is there in the list that we have to identify. So for that we need 4 field. First field row, and second field column, third field value. So up to this point, up to these 3 points, we know that array representation only. Similar. Okay. So the next point is next node. Okay. So if the 3 nodes are this is the first node. Okay, node 1, because row column value will be there. Next another node is there. Row column value is there. This is the second node. Okay, so maybe third node will be there. Row column value. Okay. So what we have to do? This is stored here. This is stored here. This is stored here. So I want to represent where it is stored. So this I will create one pointer. That pointer is pointing to this next node. So like that, another one space will be there. That will be pointing to the next node where it is stored. So this is actually linked list. link will be generated for in the list to represent where the data are stored. Okay. So we need 4 field like represent that sparse matrix using linked list. So first one is row and second one is column, third one is value. These 3 are similar as array representation, but the last one is pointed to next node. Okay, so same sparse. This is the sparse matrix. So here 4 cross 4 matrix are there containing 5 non-zero element is there. Okay, so 11 zero elements are there. So here 4 into 4 means 16 memory space is required, but increasing the size of matrix will increase the wastage of space. So for that we have to create the memory and we have to use sparse matrix to reduce that using linked list representation. The last node pointer is pointing to null pointer. Okay, so this is null pointer. That means this is the last node in the list. So for that we are using structure concept. Okay, so we have to create the node whenever we are representing the list. So we need to represent the node. So that node how many partition is there? One is row. Okay, one is row. Another one is column. So column position. Okay. So next one is value. Okay. So next this is the pointer I said no. We are created one pointer. Okay. So for this we are created the structure. Structure how to create it? Struct keyword structure name. Okay. So then these are the structure elements. So after creating the structure, we can represent that linked list. So this is a sample program. So using this sample program, we can represent the sparse matrix. Okay. So now you just understand how it will be identified. Okay. So if R tends to value means wherever that node is created now, so R is the pointer. It will allocate the memory. M allocation means memory allocation. So dynamic memory allocation, it will allocate number of nodes. How many nodes are there? This pointer, it will allocate the memory. This pointer is how the pointer will be represented using arrow mark. Okay. So the pointer to tends to value is non-zero element. If any non-zero element is there, that will be assigned to value. So if the for that element, what is the row index? What is the column index? That will be assigned to row position and column position. So finally what we have to do, R tends to next equal to null. Null means the last node is representing null. Okay, clear. So again the pointer is assigned to temporary pointer. So what we have to do now, so there is we have to check row and temporary pointer, all pointer at the same position, starting position. Okay, R is the pointer, S is the pointer, start is the pointer, and temp also pointer. All are pointing to the same location initially. Okay. So row position we have to check. It will print row position. What is the row position? Temp equal to not equal to null means temp tends to row position. So the pointer is pointing to that particular position. It will be printed. Okay. So we have to initialize the matrix. So after finding that row and column values, we can initialize the values. Then remaining things are we know how to represent the sparse matrix. Okay. So finally execute this program. We have 3 portions: row, column, and values. The fourth one is pointer only. No, the pointer already pointing to where the next node is stored. Okay. So this is the final output of this linked list representation. So now we are discussed about array representation and linked list representation of sparse matrix. Okay. So now you are in the position to answer the question. This is a reflection part. I will give 10 seconds time. You find the answer. Okay. A 5 cross 5 matrix have 9 non-zero elements and a 8 cross 8 matrix have 48 zero elements. After finding a sparse matrix, you have to find the sparse matrix for both array 5 cross 5 as well as 8 cross 8. You have to find that sparse matrix. After finding the sparse matrix, which matrix is best with respect to memory and access? You have to choose. Okay. How much time? I will give 10 seconds time to find which is the best one. How it is best also you can think. So write the answer in your notebook. I will check. So answer is 8 cross 8 matrix. Why? 8 into 8, 64 memory byte is actually required. But 48 zero element is there. So remaining element is only 16 elements. So we have to allocate only 16 elements memory. No need to allocate all 64. But 5 cross 5, 9 non-zero element is there. So 9 non-zero element means 3 into 9 non-zero elements. So totally 27 space is required. So if we allocate normal matrix, 5 cross 5 means 5 into 5, 25. So 25 elements we can allocate. But if we are creating the sparse matrix, we need 27. So compared with this, the 5 cross 5 it will take more memory with the actual memory, but 8 cross 8 have very less compared with normal matrix. So 8 cross 8 is best in view of sparse matrix. So we are in the end of the session. So already we have discussed about what is a sparse matrix. A matrix have more zero element, that is considered as a sparse matrix. We have to remove the zeros and we have to represent that matrix, that is considered as a sparse matrix. How we can represent? We have two ways to represent. One is array, another one is linked list. In array representation, we can use a two-dimensional array using representing row and column positions, and finally we can represent that value. With the value we can represent the sparse matrix. In linked list we have to create the node. Each node have row value, column value, value of the given, then pointer to the next node that will be stored. So using this we can represent the sparse matrix. With example programs we are explained both the concept. Now, so this is for your lecture learning problems. Okay. So here you just read, develop a C program to allocate memory. While develop a C program to develop sparse matrix for given matrix and show the efficiency of the sparse matrix. First you have to use allocate the memory. Then you can find the sparse matrix. Finally you can check which is the efficiency matrix. So now we are end of the session after lecture outcome revisited. Having completed the discussion on sparse matrix concept, now students should be able to develop a C program to create sparse matrix for the given matrix and able to compare the sparse matrix with normal matrix. So I hope you are enjoyed this video. You understood the concept of sparse matrix, how to generate the sparse matrix based on the given matrix. So even if you have doubt, you can refer chapter 3, 3.15 sparse matrix in Rematharaja textbook. Further doubts, you can refer the weekly tutorial sheet. Thank you very much for listening this video with concentration. Okay, if further doubts, you come for discussion in the classroom. Thank you very much.